Welcome back to our channel, and let's start today's video. And it is a continuation video about the Spark Submit, and we are learning about how to submit a job in Spark. Suppose we are running a job in a Spark environment like EMR or something. There, how we'll submit our job. So till now, what we have discussed is uh, we'll submit a job in a Linux interface, or you can say command line interface. Okay, Linux server. We'll submit a job. There we'll write our job submit. Comment like this: Spark hyphen submit. Then master will mention as yarn. Deploy mode cluster or client. Please go our previous videos. There's a part 3 video of the Spark Submit. Check out the part 1 to understand the cluster mode and client mode. So then the name of the job, then how much driver memory we need, 4 GB or 8 GB or 10 GB, okay, or 20 GB. How many cores in driver will need, then executor memory, then executor how many cores, the number of executor, how much executor we need. To understand this portion, please visit our architecture, Spark architecture video number 2. That will help you a lot to understand this. Then we'll provide our script with the path of the script to run that job. Run that application or job, whatever you say, ETL job. So it will process, okay. But there is much more than this. This is a basic setup, okay. And we'll going to discuss the secondary things. Last video we have discussed all the green mark things, but today we are going to discuss this yellow mark started with dynamic allocation. So today's topic is dynamic allocation, how we'll configure the dynamic allocation in Spark, why we need this, what are the benefits, okay. So we are going to discuss this. Then in the next video we'll focus on the partition or ADQ, any one of that. So today we are going to discuss about dynamic allocation. Let's start our video today with the dynamic allocation. Let's try to understand dynamic allocation in a better way. So dynamic resource allocation in Apache Spark, this is our topic today. So what is this? What is dynamic resource allocation? To understand this, we have to little bit go through with the architecture. So as we know, when we submit the job, Spark session and driver will get created. Then resource manager will allocate the resources. Suppose we have yarn as a resource manager, it's allocating the resources. Like we have requested for 4 executor or 10 executor. Suppose we have requested for 10 executor, okay. Now what is dynamic allocation? So every time when you will run the job, it is not fixed that every time you will need 10 executor, okay. Sometime maybe your job, your task will get assigned into the executor cores, right? And suppose in each executor you have 4 core, okay, and 20 GB RAM, okay. So suppose your job is getting assigned to executor, so 4 tasks will get assigned into one executor because one executor has 4 core. So like that, suppose you have maybe 25 jobs, okay. So first it will get assigned to every executor. So 25 tasks you have, and there's 10 executor, okay. That's mean 10 executor, we have around 4 into 10 equals to 40, but we have task 25, right? So 25 tasks will get assigned into 25 cores. That's mean we'll need around 25 divided by 4 is, so we'll need around 6 or 7 executor in that case to complete the task, not the 10 executor, right? That's mean while completing the task, our 3 executor extra resource which we have allocated, that will sit idle, right? And in that case, what will happen, suppose our someone from our team which using that same EMR, okay, they want to use that resource, but they will not be able to use that resource or utilize that resource because we are already using that resource, and we have already took the resource and created the resource, right? So that's mean the resource wastage is being happening there, right? So in that case, dynamic resource allocation can help us. Let's see how it can help us in this case. So before starting the video, guys, I would like to introduce myself in this video. So my name is Ganesh Ghosh and I consider myself as a learner. I have completed my master degree in data science. I have completed my MBA in operation management. I am Apache Spark certified by Databricks, the mother company of Spark, and Databricks certified data engineer. And I am carrying 8.5 years experience as a data engineer and AI enthusiast. I also have Snowflake certification. I am currently completing AWS AI certification, and below you can see my skills, and that's all about me. Thank you. Let's continue with the video. Yeah, so content. So we'll discuss in this video what is dynamic resource allocation, why use dynamic allocation. I mean, what is dynamic allocation? We just have discussed that we need to dynamic if we need to dynamically allocate the resources. In that case, we need to use the dynamic resource allocation, or DRA. Okay, and why use dynamic allocation, how dynamic allocation work, key Spark configuration, and all that, best practices, real life scenario, those things we're going to discuss here. So what is dynamic resource allocation? We just discussed about this. Let's refresh. A Spark feature that adjusts the number of executors dynamically at runtime while Spark is running inside that. So you have submitted your job, right? But inside that you cannot do anything after submitting the job from the outside, okay? But if you configure this dynamic allocation while running the job, it can handle the resources by itself uh, inside the Spark application. You don't have to do anything from outside. Anyways, you cannot do anything from outside. If you want to do, you have to stop the job, then do something in that, and then rerun again. But if you are using dynamic allocation, as per your need, your resource will get allocated or removed. Okay, and when I'm saying resources, I'm talking about the executors, okay, not the RAM or core. That is not possible, but you can allocate or remove executor while using this, using the Spark. Okay, scale resource based on the workload. If it is idle, it will remove it. If all the executor is busy, you can allocate one new executor. Okay, help optimize cluster utilization and reduce cost. So more resource mean more cost, right, guys? So we know this already. If there is 10 executor available instead of 7, if we need 7, there is 10, we are specifying, that's mean more cost. And we cannot provide 7. Suppose this time we need 7, but 5 minutes later or 10 minutes later we'll need 10 executor, right? So it is sometimes it's kind of difficult to calculate exact figure what we need. In that kind of time, dynamic resource allocation can help us a lot. So moving forward, why use dynamic resource allocation? I mean, why you need to use this? As we have discussed, intelligent scaling, we don't have to do anything from outside. Okay, Spark will check, I mean, which executor is sitting idle. You'll specify a time, okay, like you can specify check 60-second is timeout. If any executor sitting idle more than 60 seconds, we don't need that executor, and remove that executor for the time being. Okay, and suppose your tasks are getting queued. Okay, I mean, all the other executor is busy, your task is started getting queued. Okay, and your task is waiting in the queue more than 2 seconds, 3 seconds. Okay, In that case, you can specify the time, the seconds, okay. And in that case, your uh, Spark job, you're using dynamic resource allocation, it will automatically assign another executor in that case, okay. So that is why it's called intelligent scaling, okay. Frees frees up resources when idle, acquire more when needed, okay. Cost efficiency. Why cost efficiency? Reduce over provisioning. So suppose, as I provided the example, I have provided 10 executor, right? And suppose in that time I don't need that much resources. I mean, executors are acquiring the RAM and cores, right? And that time, if they are not using that, it's mean if our Spark job not utilizing that, other worker or our other colleagues can utilize that to run their Spark job, right? So in that case, what will happen? If it is not being used, it will remove that, so it will save our cost, right? So better resource utilization, handle workload spikes without manual training. I mean, suppose when the workload is increasing in the morning at 9 a.m., our workload will get increased, okay. That time we'll need more executor, so it will assign that executor by itself. You don't have to do anything, just you have to configure. While doing Spark submit, you have to configure your job according to that. We'll see that. uh, Driver program schedule the task, and task scheduler handle this task assignment to the executor, okay. Now, executors, we have dynamic scaling. We have set it up, DA, dynamic resource allocation, DRA, okay. So now what will happen? External, suppose shuffle service will be used, then dynamic scaling up or down based on the queue size or idle time that we have discussed will happen, okay. Now what is this? Number 4, external shuffle service. Now what will happen? we have we have discussed that we'll do when we'll do some uh, transformation, white transformation, that time it will happen. What will happen? Shuffle will happen, data shuffle will happen. Data will move to one partition to another partition. That time what happened? That time, while doing that, our executor saves some data or file, you can say, into the storage or hard disk, okay. So split some data into hard disk, okay. So suppose a executor splitted data into hard disks, okay. Now your executor was sitting idle. The executor splitted data into the hard disk, that has the information where it splitted the data, I mean where it put the data in the hard disk, okay. But your executor sitting idle more than, suppose you set it up 60 second, okay. So after 60 second, that executor will get removed automatically. The data from that executor and all the resources like RAM code will get removed from that executor, okay. In that case, what will happen? The location and the data it's saved into the disk, that will get lost, right? But external support service will help us in that case. So when any data will get splitted, I mean when any executor will put any data or file while doing the shuffle operation, that time this service, ESS, external shuffle service, will also register that this executor put this data in that particular location, okay. Now even if your executor got removed, that will not affect anything, because your ESS already registered, your external shuffle service already know the place where the file is written. Then suppose your another executor need that file, ESS can easily provide that file location to that particular executor. Otherwise, if there is no ESS available, what will happen? Then your job will start getting failed, or retries will start happening, because your other executor will not be able to find that file, because the status or the location of the file also got removed with the idle executor when it got removed, okay. So let's move to the next part. So scenarios, okay. Lock When we can use this, let's discuss this scenario, okay. So scenario is log processing pipeline. We are processing logs which is getting generated, suppose in our EC2 instance, okay, or S3 bucket. Let's take logs are getting generated and we are trying to process that log. So we are running a Spark job that process logs from cloud bucket. In case suppose S3 bucket, our logs file are getting generated every hour. Okay, every hour it start processing the log. Okay, then complete it and stop. Okay, the job process 1 GB during most hour. I mean, from in other hours, like 7 a.m., 8 a.m., is process 1 GB of file. Okay, but spike hours, like you can see here, spike hour like 9 a.m., due to more traffic in the website. Suppose there is 50 GB of data is getting generated. Okay, so 50 GB data now, instead of 1 GB there is 50 GB of data, so more data, right? We'll need more executor in that case. Okay, now from the outside you cannot just allocate that, right? Because if you want to allocate the more resources, then you have to stop the job, and that is not possible. But if you are using DRA, dynamic resource allocation, what you can do in that case, you would provision 50 executor all the time to handle the peak. Okay, so how you will do that? You will mention that maximum 50 executor you should use. Okay, this is just a number. This number can be 100, as per the your uses can be 40. Okay, just an example, suppose you have provision maximum used executor 50. Okay, so in your peak hour it can extend till 50 executor. Okay, with DRA, job start with 4 executors. Suppose other hours like 8 a.m., when there was 1 GB of data, that time your execute there was four executor was started. Okay, at 8 a.m., 4 executor start working. Okay, in your peak hour, DRA initiated and launch more executor, like till 50. You have mentioned the highest number is till 50. It can, as per the requirement, it can increase the number till 10, 20, 40, 30, whatever it want. Till 50 it can use, up to 50 when needed. Okay, scale back to 4 or 1 when idle. Suppose your job is done at 9 p.m. to 10 p.m. 9:30 your job is complete. Again your job will start at 10. Okay, and in 10 you are seeing there is only few data available. Okay, not even 1 GB. Okay, now your executor will get removed by using DRA. Okay, dynamic resource allocation. The system is intelligent and itself it will remove the resources, like it can take that down to 4 executor, or even if needed till 1 executor. Okay, your maximum limit is 50, you have said. That's minimum. Minimum is 1. Okay, 1 executor. It saved the 80% of the cluster resource. So I hope we are able to explain. I mean, I have explained it very clearly, the what is auto scaling in this case. Okay, what is dynamic resource allocation. Let's move on how we will do it. Okay, so we have discussed here in the Spark submit the few things, like we'll will set up these resources. Okay, now how we'll manage additional resources here. Okay, let's take this to a notepad. That will help us. I mean, I always prefer notepad, and that's very helpful to me. Okay, let's put it here. Okay, so this is the command line interface. In the command line interface we'll allocate our resources. Suppose we want to active the dynamic resource allocation. Okay, how we will use that, we are just going to see that here. Okay, so first thing first, what we have to do, we will take this. So first we have to enable dynamic allocation. Okay, for that what we will do, we will just put it here. Okay, like this, Spark dynamic allocation dot enable. Okay, here we will put as true. Okay, then we'll come down, and then this is ESS. We just discussed earlier what is ESS, external support service, few seconds back. So we are enabling the ESS, external support service. Okay, so here we'll enable this, and we'll put it here equals to true. Then here the third one is dynamic allocation minimum executor. So we need to provide the count of minimum executor in the lower state when our data is very minimum. How much executor we can go till down. Okay, so here we can mention, like, at as we saw the real life example, suppose at 11 a.m. our data is around 100 MB, okay, or 500 MB. Okay, that time we need one executor only. Okay, so it will take our resources, I mean executor, down till one. Okay, then we need to mention the maximum till how many executor a dynamic resource allocation can create. Okay, for this we'll use this configuration, and this is called dynamic allocation maximum executor. Okay, so we'll take this and put it here, and we can put here the number. Okay, remember guys, I'm doing it in the notepad, but after completing it we have to put it in the our system, I mean where in our Spark environment where we are trying to run our Spark job. Okay, and that is of course not the notepad. Okay, and maybe EMR we are using. I basically use EMR, that's the reason every time I give the example of EMR. So I'm AWS professional, so EMR, glue, those things come handy to me. So idle time, executor idle time, this refer to how much time or how long you want to wait a executor in the idle state. Then you want the resource manager, or yes, the resource manager, to remove this. Okay, using dynamic resource allocation. Okay, so suppose I am saying wait for 60 seconds, not more than that. Okay, so uh, wait for 60 seconds. If you are seeing any executor is sitting idle, I don't need that executor, just remove that executor, save my cost. Okay, so in that way 60 seconds you need to mention. Then you have to mention how long a task can wait in a line or queue, okay, before it get assigned to any executor. Suppose all the executors are busy. Okay, suppose you have 7 executor currently, your executors are busy. Okay, then your task is sitting idle, right, I mean in the queue or in the line. Okay, then your resource manager, what it will do using dynamic resource allocation, it will just assign one more executor, okay, for your task, so that your tasks don't get idle. Okay, don't sit idle. So a new resource will get, or new executor will get added here. Suppose I want to mention here 2 seconds, don't wait more than 2 seconds. Okay, so this is how we allocate dynamic resources. Okay, I mean we configure the dynamic resource allocation. This is the way, this is the thing we do. I mean you can remove these things, that is not an issue. This just help us to skip the line. Okay, so you need to use this in your interface if you are skipping the line. What I mean is by skipping line, suppose this is the first line and this is the second line, this is the third line, we're skipping the line, right? So this is the basic configuration. In that case, if you want to use the minimum resources, and also you want to use, in that case you don't have to mention this number of executor thing. Yeah, so yeah, this will be the basic configuration, because you are allocating the resources, I mean the executor, using the dynamic resource allocation. You don't need to mention the number of executor, that's its static value. If you want to create the dynamic, I mean not want to use the dynamic resource allocation, that time you need to mention how many resource and how many executor you'll need to complete that job, total application job, I mean process the whole data. Okay, So this was the thing. And few things we need to keep in mind: always enable Spark supple service. Enable, I mean, that external supple service, because we have discussed the benefit of it. Okay, external supple service, you just to follow the second line, just have to follow the second Spark supple service enable. Okay, enable external supple service, just do it equals to true, that will work. And then set resource reasonable minimum or maximum executor limit. I mean, you have job 1 GB and your job can get increased to 5 GB. You will not put in that case you will not put 50 executor, right? Maximum limit. I mean, if you are putting that and your system started to work, get till that, your cost will be so high than the expectation, right? So that will not be an ideal situation. Everything has its pro, has its con. So we need to learn how to optimize the jobs and how to utilize the dynamic resource allocation itself. Okay, so set reasonable minimum or maximum executor limit. And why minimum? Suppose you are working with 5 GB of data. Okay, and you are setting up minimum one, and your uh, dynamic allocation resource manager set up executor one, uh, and your job is not running in that condition. Or suppose you have 50 GB of data, your executor manager or resource manager setting up one, that will be not idle in that situation also. So set a minimum and set a maximum carefully. Okay, here I have set one, but minimum I always think a executor should have, I mean, the number of executor we should have is 4. Okay, that's my understanding, the amount of or volume of data I have worked. So I need at least 4 executor, okay, in the minimum situation, not less than that. I mean, yes, I can wait, but if that is taking lots of time, right? And taking time, means time is money, right? So we cannot wait so long, right? Yeah. Monitor executor behavior using Spark UI. Monitor executor behavior using Spark UI. Use metrics to tune idle timeout value. Okay, be cautious. In streaming job, dynamic allocation is not idle. I mean, streaming job, streaming data you are processing, don't use the dynamic resource allocation in that case, uh, because we need stable resources in while processing the streaming. Okay, so yeah, that's it for today, and thank you for being with us in this video. I hope from this series you are learning a lot. Please like, share, and subscribe our channel, and stay tuned. Thank you.